Hello students. Today we're going to learn about composite functions. Let's begin with this warm-up. Using the two functions f of x and g of x here, go ahead and evaluate them. Okay, looking at number 1, f of 2. So we're going to write that f of x equals 3x minus 4. So we're going to replace x with 2. So f of 2 would equal 3 times 2 minus 4. Just a quick substitution here. So we end up getting 3 times 2 is 6 minus 4, which is 2. Now the same thing for number 2, g of negative 1. So looking at g of x up here, so let me write that down to show my work. G of x is x squared minus 4. I need to take out the x and put in negative 1. So g of negative 1 would equal negative 1 squared, notice the use of parentheses here, minus 4. Negative 1 squared is positive 1 minus 4. So 1 minus 4 is negative 3. This will be a really helpful warm-up as we get into the lesson for today. So at the end of this lesson, you will be able to write the functions in composite functions. A composite function is written like this, f of g of x. So we can see that as f of g of x, said the same way. And this should really have an x next to it right here. And again, to say this out loud, so I'll write it over here if you'd want to write it in your notes. This is f of g of x for the first one. And for the second one, this would be out loud, we would write g, or we would say g of f of x. And it's really helpful rewriting it. Usually a problem looks like this with this circle right here. It's really helpful to rewrite it like this, g of f of x. You'll see the examples as we do them next. So we have two functions, f of x and g of x, and we're going to do the composite functions. So this will be our first example 1 here, and then we'll do a different one, for example 2 after that. Okay, so first it says f of g of x. It's really confusing looking at it like this with this little circle here. So first I want you to rewrite it using this notation, using the double set of parentheses. So f of g of x. Okay, I'm going to try to make this as simple as possible. So what we need to do first is just rewrite this with the f. So I can rewrite f because it says f right here. Now instead of g of x, I go up and I look to see what g of x equals, which is x squared plus 1. So let me fill that in here as x squared plus 1. So all I did was replace g of x with what it equals here. So now I'm looking at the f function, which I still need to evaluate. So now I have f of x squared plus 1. So I have, here is my f function here, and I'm going to write it, so 2, and instead of x, I'm putting in x squared plus 1. And then I still have plus 6 at the end. If it helps, you can circle up here and show the substitution that way. So what we're doing, we're taking x squared plus 1, we're taking the g of x, and we're putting it in right here for x. So notice what I wrote. We have 2, and then instead of the x, we have x squared plus 1, since that's what g of x is, and then plus 6. This is the most important step. The rest is algebra from here. So once we get the correct way to plug it in, we just need to distribute. So we have 2x squared plus 2 plus 6. Notice I didn't distribute the 2 to the 6 because the 6 is not in parentheses. Simplifying one more time, we get 2x squared plus 8, and that's the final answer. Okay, let's go ahead and try example 2. So this time we're doing g of f of x. So this looks confusing how it's written here. I want you to rewrite it using the double set of parentheses. So g of f of x. So write it just how it looks. So this time we're going to write g, because that's what it shows first. Instead of f of x here, I'm writing in what f of x actually equals. So in this case, f of x is right here, 2x plus 6. So it's identical to how it's written right here. Okay, let's go ahead and plug it in. So I'm taking 2x plus 6 here, and I need to plug it in for x in the second part, in the function of g. So now I have 2x plus 6 squared plus 1. So again, look at what happened. You can, if you want to pause your screen and rewind, you can do that also. We have 2x plus 6 going into the g function. So it's getting substituted right where that x is. So now this will take a little bit of time to simplify. Let me skip down a little bit here. So we have 2x plus 6 squared, so I'm writing that twice, and then plus 1. Notice I didn't try to distribute this exponent of 2. You are not allowed to do that. You need to write it out twice and then FOIL. So first would be 2x times 2x, so 4x squared. Outer is 12x. Inner is also 12x. And last is 36. And we still have the plus 1 at the end. Simplify, so you have 4x squared plus 24x. I'm combining the outer and inner terms. And then plus 37, these parts here. Okay, again, I know you may have gotten lost in some of the work, so make sure you go back, pause the screen where you need to, and really study how these substitutions took place in these composite functions. Okay, you guys try these two problems, and then I'll see you in class tomorrow.